at the problem compared to the mobility of holes in silicon, the mobilities of electron is what? So it's impossible to determine, smaller, larger, same, or none of these. So again, we're going to be comparing to the mobility of holes in silicon, electrons. So we're comparing holes and electrons. Super important. So when we look at our notes, in the description below, like button, not my notes, professor's notes, just screenshot it and put it in Google Docs. We have figure 3.19, no electrons versus electrons for our zero gate voltage when we're switched is closed. So whenever we have an electron channel, we have a bunch of electrons in here. We can see that we have a bunch. Now, this is when we have negative Q. Let's go down a little bit and let's look at holes, 3.20. Well, when we look at holes and we close our switch, we can see that we don't have many holes in here. We have a plus Q and we have these P's in here. We can see that everything's a little bit different when we have a current flowing through our N MOSFET. We have N right here, and then our channel is P. And when it's a P FET, we have these two parts as P, and then our channel part as N. So with N, we are going to have holes in here. That means that we have less just by looking at this drawing. Because if we have just these holes here, and we have these electrons here, well, we can clearly see that we have more electrons than holes. So the answer for this problem is going to be larger. Compared to the mobility of holes in silicon, the mobility of electrons is larger. We have more electrons when we're looking at the behavior of our P FET versus our N FET.